you guys for staying that long on a Friday afternoon. So over the next 20 minutes or so, maybe half an hour, I want to tell you a bit more what we've been up to, tell you a bit more about these technologies, Substrate and Polkadot, and how we believe we can actually, support innovation in this space and enable a lot of these use cases that have been talked about over the last couple of years so extensively. So, a bit about myself really quickly. So, as said, I'm Chief Commercial Officer at Parity. Our company was founded in 2050 by key alumni of the Ethereum Foundation, most notably Gavin Wood, who back then had written the Ethereum yellow paper and implemented the first implementation of Ethereum. Back then it was a C++ client. After that, we ventured out, founded our own private company in the UK. We are headquartered in London, have since grown in different parts of the world. One of our larger offices are in Berlin, in Germany. That's where I am based. And we really, when we got started, our goal was really to enable a new generation of application engineers to fundamentally reinvent the way and means how we architect applications and enable new ways of providing digital services over the internet. Now, back then, for the first year or so, we really concentrated on implementing the most advanced Ethereum client and really growing an excellent team and building a team for the future. And I would think we have accomplished that since roughly 2016, late 2016, Parity Ethereum has actually been the primary choice for players to secure the Ethereum main network as well as to interact with it, particularly among infrastructure players such as miners and exchanges. Now, along the way, we have, ventured out from the Ethereum space to implementing software and supporting other public networks, such as Bitcoin. We have implemented the production-ready Bitcoin implementation, as well as the Zcash implementation, and are now building Polkadot. But along the way, we have as well worked together with a couple of larger organizations to showcase the power of the software in an enterprise setting. And in fact, last year in 2018, Parity Ethereum was the most deployed solution on Microsoft Azure. Now, I'm just going to walk you through one of these use cases that we have implemented together with the United Nations World Food Programme a couple of years ago, and which has been running for a couple of years in production. So, as some of you might know, the United Nations World Food Programme's goal is to fight hunger in the world, right? And they provide roughly aid to roughly 80 million people in 80 countries. And over the years, they've figured out that cash transactions are actually more efficient than food deliveries in the markets where there is existing infrastructure, such as supermarkets or markets where you can buy food, right? So let's take the example of a refugee camp, a Syrian refugee camp in Jordan. Now, there they have the infrastructure to access food, right? And so far, in order to facilitate cash transfer, they had to partner up with local banks in order to distribute the money to the local banks and from there to the supermarket or the food distributors in the local market. And depending on the banking infrastructure, they were usually exposed to a 1.5 to 3% transaction fee on every transaction. And they were exposed to a fairly complicated monthly settlement process. Now, they had fairly long setup times, to get the system up and running, and were exposed to fraud, coercion, and data mismanagement. Now, A couple of years ago, when they reached out to us because they had an idea how they could simplify that system and actually made a better solution, we came together and implemented over the course of half a year a blockchain-based record system, right? A system that tracks entitlements of refugees, of persons in these areas, right? With which they can go to a food vendor, a food distributor. They can identify themselves, authenticate themselves through a biometric identity system, and then the food vendor, the distributor, can check the authenticity of the person and distribute food to them directly. And then, as a next step, you have direct, immediate settlement with the World Food Programme, without the middleman of the local retail bank in that case. Now, this system has provided aid to over 100,000 refugees per month over the last 1.5 years, and it's being scaled up to 500,000 people right now. It has saved over $40,000 per month and eliminated 98% of financial transaction fees in the system. But today I don't want to talk about Parity Ethereum too much, or what has been built, or what we've been built in use cases. I want to rather give you an outlook of what is to come and what we've been building with all this experience of like being involved in such projects. Now, there's a particular product I want to talk about, which is called Substrate. It's a blockchain building framework, an open source blockchain building framework. And I want to start off with giving you some motivation around what that is. Now, nowadays, today, right? If you want to use blockchain to power your application, right? If you want to build a blockchain-based application, then you have basically two choices. Either you build on top of a smart contract platform, such as Ethereum, Tezos, Corda, and so forth, or you implement your own app-specific blockchain. So a blockchain that does only what you want, that is only able to do what you envisioned, and is limited to that. You could see Bitcoin as an app-specific blockchain because it was built for one purpose and does only that. Now, I would make the case that we haven't seen a lot of these app-specific blockchains over the recent years and more innovation on smart contracts. But there's good reason why you would want to implement an app-specific blockchain. So some of them are, for example, performance. Often in smart contract systems, the smart contract VM is the bottleneck, right? It wasn't optimized for what you want to do with it, right? It was built to be as generic as possible and allow everything, right? So often that's a bottleneck, but if you could, optimize it for your use case, you could get greater performance. Second one is security. Because smart contract platforms need to be that general and need to allow all these use cases at runtime, right? There's a really large attack surface. So it's hard to secure them. It's hard to reason about the security of them. Another one is sovereignty. If you share the same infrastructure, the same runtime, the same state machine with other projects, such as the case in Ethereum and so forth, you're dependent on the platform's governance. Last but not least, flexibility. There's always a trade-off. Even if you try to make a smart contract platform as generic as possible, you still have trade-offs. And there are still things you may not be able to implement effectively. An example, you will probably never be able to implement a high-frequency trading machine on the current Ethereum virtual machine. Now, why hasn't anyone else bothered implementing app-specific blockchains if there are good reasons for it? Well, building a blockchain from scratch is really, really hard and expensive. It takes loads of really well-equipped developers that have tons of experience, right? But over the last couple of years, we've actually done it 4 times with our now 70+ developers. Ethereum, Bitcoin, Zcash, Polkadot. And when we get to Polkadot, we were at a point where we said, we get to a point where we were like, do we really have to do that every time from scratch, right? And we realized there are a lot of parts in a blockchain that are actually the same, right? If you look at Bitcoin, Ethereum, and these blockchains, I would make the case that 80% of the code base is actually pretty similar. You know, the database and other parts. So what we said is, hey, we really should take all these learnings from implementing different blockchain clients and make this, you know, this work available to everyone, right? Make it feasible for somebody to implement a blockchain from scratch without, you know, doing all the hard lifting work, right? So we set off to implement the framework that we call Substrate. It's an open source, modular, and extensible framework for building blockchain. And you can see it as a very generic bed of technology, right? To help and really support innovation in this space and let people focus on the parts where they can make a difference rather than trying to implement another networking library. Now, what does Substrate provide you with? Right. Substrate provides you with all the core components of a blockchain: database layer, networking layer, consensus engines, transaction queue, and a library of runtime modules. And importantly, each of these modules, each of these components can be customized and extended. Now, what does that look like? If you, I brought a diagram here. So on the outside, you have all these fairly boring parts of a blockchain, like an RPC layer, the sync layer, libp2p is our networking layer, the database that's really optimized for these operations that are needed in blockchains. And last but not least, maybe if you want a contract module, a contract language. Now, this is all being held together by a consensus layer. And again, there are multiple consensus engines available to use. Within that consensus kind of layer, you have a WebAssembly execution environment. And for those of you that are not aware of what WebAssembly is, so WebAssembly is a new binary format that provides a secure sandbox while being designed to run at native speed, so being extremely performant. And the nice thing, it's platform independent. It's very portable, right? And within that execution environment, we have the runtime. And the runtime is really, in my opinion, where the magic happens. That's what you guys should be excited about. That's what you guys should be looking at. Because the runtime, at the end of the day, is the block execution logic of any blockchain, the state transition function. And if that all sounds strange to you, well, think about it as the business logic of a blockchain. That's where you say, what features should my blockchain provide to its users and developers? Now, it's nice to have, you know, this ability to implement your custom runtime, right? And say like, hey, you know, I want it to be only a reserve currency and only optimize it for that single use case. And I can reason that it's very secure because it does only that and it does nothing else. But if everyone would implement their own custom runtime, right, you still had to do quite some work, right? And that is why we set out a framework which we call the Substrate Runtime Module Library, which again lets projects piggyback on the effort that other project has done. Basically, it's a set of modules that you can pick and mix them and put them together, and you get your blockchain runtime that you want. As an example, you see loads of modules that we have implemented already, but any modules that would be implemented by enterprises or other projects would be compatible. So one example for a module is assets. Assets is a module that gives you, it's a fairly simple module that gives you simple, secure, additional on-chain fungible assets. So assets that can be transferred. Another one is council. Council allows you to do elections on a blockchain. It's a governance framework. It allows you to submit proposals and vote on them. And we have many more of these modules that are already available today. Now, this is all great, but not necessarily that enterprise specific. Now I want to talk a bit more about enterprise specific stuff. There are some requirements that you see in the public blockchain space as well, but that are especially important in the enterprise space. Security, performance, upgradability, permissioning, privacy, extensibility, governability, integrations, available integrations. Now, let's go through them and see what Substrate provides you with. With regard to security, consensus is a very important part to look at if you want to reason about how secure a blockchain is. Now, Substrate, as I mentioned, features pluggable consensus. That means you're not locked into using one specific consensus engine, but rather we designed an interface that allows other people to plug in different means of coming to consensus. Substrate comes prepackaged with two kinds of consensus engines. One is a PBFT engine with one block finality. The other one is more of a hybrid engine that that is added with a very progressive and adaptive finality gadget. To give you a bit more context of what all that means. In engineering, it's generally all about trade-offs, as you might know, right? And blockchain systems are really no exception here. Let's take the case here of consensus. There's an FLP impossibility theorem that you might know that states that safety and liveness cannot be simultaneously guaranteed by any consensus algorithm. So that means there's a trade-off. What does it mean? Right? Simplified, explained, right? Safety can be seen as something that should guarantee that a bad thing never happens. Whereas liveness guarantees that something good will eventually happen, right? That these features that a blockchain gives me are available to me, they are live. Now, this impossibility theorem says we can't have both at the same time in consensus engine. It just doesn't work. So we have to prioritize one over the other. And to give you an example, these engines that I mentioned, the PBFT engine prioritizes safety over liveness with one block finality, whereas the hybrid engine prioritizes slightly liveness over safety. So whatever your use case is, right, you got to determine for yourself what is more important to me in this specific case and choose the engine that fits your needs. Now, there's some other technical intricacies and technical details that are fairly interesting around what crypto we use, but I won't go into details. Now, with regard to performance, we implement most of our stack in Rust because it's a very, very, very fast, very performant, and a secure language. Our primary implementation is implemented in Rust, but the WebAssembly, the runtime can also be implemented in WebAssembly, and you can have smart contracts if you want. To make that all faster, we are experimenting and have been implementing a single pass optimizing WASM compiler, which is really cutting edge, but I think it will see the light of day very soon. Last but not least, we have a scale encoding and decoding scheme for very high efficiency that is faster than a regular JSON RPC proxy. Now, extensibility, what does it mean? Basically, it means you can extend it by what your needs are, right? You're not locked into one specific smart contract framework. You have the full design space of implementing a runtime. It's a generic framework in that sense. You have this runtime module library. You can upgrade consensus if you want. You can upgrade runtime if you want. And if you build on Substrate, you can plug it into Polkadot eventually. Now, I will talk about most of these things in more detail in a bit, but one specific trade-off I want to make you aware of again is the trade-off between technical freedom and development ease. Now, right? You can use Substrate in three different ways. We have three different layers of abstraction. On the very left is, let's start with the very right, is Substrate Core, right? It's more of a bare bones library that gives you core parts such as consensus and a lot of the stuff I've used to, but that doesn't make any, that is very unopinionated what the runtime should look like. Then you have Substrate SRML, the Substrate Runtime Module Library that I said. It's kind of a framework that makes it easier, to piggyback on what other people have built for runtimes. And we get to a bit more of a concrete implementation, but as further we go to the left, it becomes easier to develop. And on the very left, you get a prepackaged Substrate implementation, a prepackaged node that you can just start with in like 2 minutes. Now, upgradability has, in my opinion, be a bit of an unappreciated area. Let's talk about upgrades and forks for a bit. So, I think that is an area that is extremely important. As you might know, in an enterprise, oh, you will know that, right? In an enterprise scenario, a blockchain fork can lead to a catastrophic disruption of business processes. If you don't know what a hard fork is or a blockchain fork, it basically means that a network partitions and one part of the network believes A is the truth, the outcome A was the truth, and part, like the other partition of the network thinks, no, the outcome was a different one, right? And that's absolutely catastrophic and unacceptable. Now, forks can be caused by two different things, mostly. Either diverging implementations of a protocol and bugs in the software. The other one is a failure in the coordination around the upgrade process. So let's say we say the blockchain as it stands today doesn't facilitate certain features that I need, and I need to upgrade the blockchain. What do? You try to coordinate with all these players that run the software to upgrade them. If you fail to do that in a clean way, you get to a fork. And we've seen that in the public blockchain space a few times, in Ethereum, in Bitcoin, and so forth. And it's pretty catastrophic. Overall, I believe enterprises will have a need to upgrade a chain, and blockchains in general are meant to be systems which persist for a very long time, and there are no perfect blockchains today. And it's very unreasonable to assume that there will be perfect blockchains for the foreseeable futures, right? And even if they were perfect today, they wouldn't be for long, because we have new research, new technology that we would want to incorporate. So we will have a need for upgrades, be it for fix of important security vulnerabilities, be it for change of core rules in the protocol, be it for adding new functionality, or, fixing bug, repairing chain state. But the problem is, today upgrades, and today's software, blockchain software upgrades, require a huge amount of coordination. And even if you put in that huge amount of coordination, you can still end up with a hard fork, which is catastrophic. Now, since we thought that this is such a critical part to be solved, we put a lot of effort in that and came up with the following scheme, which is a forkless upgrading system that comes inbuilt in Substrate. Basically, what you do is you have some kind of you agree on a new update on for the blockchain system off-chain. You come together, develop new features, whatever, and say, that is what we want to upgrade to. You upload it to the blockchain, get consensus over it, and then you have a governance module that lives within the blockchain where people, and it can be arbitrary governance function, right? You can say, like, maybe it's a council, maybe it's 10 parties that have to sign a transaction that says, like, at this block, at this time, the whole system upgrades to this new version that was committed beforehand as a WebAssembly blob, as a code to the chain. And then all nodes in the system see that consensus, that we have come to consensus over that upgrade, and when the time comes, all nodes will automatically upgrade, and there cannot be a hard fork. There cannot be any node that says, like, oh, that wasn't agreed upon, or like, I forgot to upgrade. And I think that's an extremely powerful tool. Now, and that counts for both, not only the runtime, so your business logic of the chain, that counts as well for the consensus engine. Now, as I mentioned, you will want to have some kind of on-chain governance logic implemented. And Substrate, again, allows you to design and implement your own custom governance mechanism as part of your runtime. But you may as well choose from one of the existing modules that we've implemented or that others have implemented. Some of the modules that you're provided with is a pseudo module, which is literally an admin module where you can define certain keys that can, send transactions to upgrade the systems. Or it's a council module where you have a council that come to consensus over upgrades. Or you use something that we call democracy, which is like token-based voting system. Last but not least, a treasury system. Now, another area is permissioning. So, because of the way we designed Substrate being so generic and extensible, you can have your chain with your roots. The framework supports for network level partition, so what nodes can connect to the network, what's the topology of the network, as well as transaction level permissioning. You could say certain accounts can do certain actions in the system, certain accounts can't do these actions. As well as what I just mentioned, account level permissioning. Now, let's look at privacy and confidentiality options you have that come with Substrate. Well, Substrate comes with support for different technologies that you can use to actually get to a point where you can use these settings in a confidential setting. One is encrypted transaction in state and distributed key generation via a system that we call Parity Secret Store. So transactions and state is still on-chain, but it's encrypted and can only be seen by certain parties that are allowed to see it. Another one is you utilize a trusted execution environment, such as the one provided by Intel SGX. And we have an extension for a Substrate to a built-in extension that you can use to utilize these trusted execution environments. Last but not least, you can add certain ZK snarks, so zero knowledge protocols, to parts of your runtime to obfuscate certain parts to other people, but still have consensus over all of that, the security over these state transitions. Another one is off-chain integration. I know in the enterprise space that's a huge deal. You want to integrate your SAP system, you need to integrate Oracle systems, and so forth. From the learnings we took from implementing Ethereum and the pain to making it adaptable for enterprise settings, we wanted built-in support for Oracle integration using a certain framework that we call Inherence framework. Now, another thing that we built in is something we call off-chain workers for trusted compute. And that is kind of the general framework that's being used to use a trusted execution environment such as Intel SGX. It basically means a node, when it tries to produce a block, can exit the blockchain world and enter a new sandbox, WebAssembly sandbox, and do other, maybe perhaps non-deterministic computations or access certain information on the internet to build a new block. Now, for building application on Substrate, we try to make it as seamless as possible to integrate with enterprise systems. You can, if you require JSON RPC, we have a JSON RPC proxy to make it easier to integrate middleware. As I said, there's no need for custom Oracle integration solutions. Here you can see a rough reference architecture of how that would look. You have your decentralized application in the corner, which can be implemented in a number of different frameworks, also using Java or JavaScript. It uses a parity codec to communicate with the blockchain implementation, which would be built on Substrate, and it can also utilize an off-chain database and what I mentioned earlier, Parity Secret Store. But I guess it's not the time to go into detail here, so let's move on here. Now, the last important aspect I want to talk about is the need for interoperability, and I think we had the chance to touch that in the panel. Now, again, I think public blockchains do not meet sovereignty, privacy, and permissioning requirements today. This is why we got to a place where we have these private blockchains. Now, the problem is private blockchains today are being built by using existing platforms that cannot talk to each other, right? And these are pretty much all of them that you will find in the enterprise phase. And that, again, leads to your silos. So the very silos that you wanted to break out of in the first place when you chose to look at blockchain. So what I think we need is a framework that allows us to build chains that can easily integrate and interoperate with each other. And this is exactly what we are trying to do with Substrate and Polkadot. So to understand, right, if Substrate is this kind of protocol that allows you to build blockchain, Polkadot is its counterpart. It's a network interface to ensure that those innovative chains that you build don't suffer from the network effects against the network effects of the incumbents, but rather prosper from being able to interoperate with all of them, right? Prosper from being able to access all these interesting assets and all these interesting applications that you find on other chains. And Polkadot really tries to do that in the most general way as possible. It's the least opinionated over what that is, what is being connected. And when it launches next year, we hope that it will start with being able to, it will definitely be able to integrate with all chains that have been built with Substrate, but as well with Ethereum and soon after, hopefully, Bitcoin and other technologies. We are actively looking in interesting more enterprise blockchains, such as IBM Fabric and the other ones, but we haven't taken a decision yet which ones we try to integrate as well. Now, if you want to learn more about all that, or if you want to make the jump over to more the public, permissionless world of blockchains, I highly encourage you to join us in Berlin for the second Web3 Summit in August in Berlin. We will have some very, very interesting speakers, and it will be a whole lot of a different experience. Now, thank you so much for listening. If you guys want to learn more about what that is I was talking about, how it might help you to implement what you want, might help you to try out new things, please reach out to us. Thank you.